Okay, so hi everyone. After watching about 4 or 5 episodes of Skins, this is my second part in logic gates, and for this tutorial I'm going to be explaining, I think it's XOR or NOR, XNOR and XOR, and just saying what they do and what they are. So let's get started. So the first gate that I'm going to explain is the NOR gate. Now as you can see it's got an N in front of it, so the NOR gate is the opposite of the OR gate, so the output is only high when neither A or B is high, which means 1. So the only time the output value of a NOR gate is 1 is where both input values are 0. So as you can see, so on the left we've got the picture of the NOR gate. Now it's exactly the same as the OR gate, apart from the circle here. Now what this means is, and it's an inverter, so it inverts the input values of the OR gate. Now initially, with the OR gate, every value was true apart from when both of the input values were false in the OR gate. Now since that's the case, it's going to switch around and be the complete opposite. So when both input values are 0, it's going to be 1, and when the input values are anything else, it's going to be 0, because that's the opposite of the OR gate. I'll go back to it. Which one's next is XNOR. So XNOR is a NOR gate, but with a line crossing the input value lines. It's represented when you're doing it in Boolean algebra or learning about electric circuits. It's sort of a circle, but with a plus in it inside of it, and you'll put A and B either side of the circle with a plus in it to represent that it's an XNOR gate. But with XNOR gate, you have a line over it to represent that it's a NOR. Whereas if you just had a NOR gate, you just have the circle and the plus. But since this is an XNOR gate, you have a circle and a plus inside it, but with a line over it to say that it's a NOR gate. So let's get on with it. So the output is only 1 when both input values are either both high or both low, i.e. the output of an XNOR gate when the input values are both 0 is 1, whereas if an input value is 1 and the other is 0, the output is 0. So as you can see, it's exactly the same as a NOR gate and an OR gate, except with the added addition of the line where the input values are. So as you can see on the right on the truth table, get the microphone ready, you can see A and B both have 0 input values and the output is 1. That's just because that's the way that the XNOR is built, because it's sort of, NOR is the opposite of OR, but then XNOR is sort of the opposite of NOR. So when you have 0 and 1, it's 0. But when you have 1 and 0, it's 0. But when you have 1 and 1, it's 1. It's sort of strange because when you have two zeros, you wouldn't expect the input value to be 1. You'd always expect it to be 0. But the way that the XNOR gate is built, the output is always 1 when both of the input values are the same. So if it's two zeros, it's an output value of 1, and if it's two ones, it's an output value of 1. So the last gate is the XOR gate, which stands for exclusive OR. So XOR looks the same as the XNOR, apart from the lack of the inverter. So if you look at the picture, it's got no inverter where the point is, and the output of the XOR gate is high when one input value is true and one is false. So if both input values are true or both are false, then the output is low. A plus sign with a circle around it represents the XOR. So as you can see, you've got A and B is 0. Or A, 0 and A input values are 0, so the output is 0. The input value of A is 0. The input value of B is 1, and it's 1. And also, it's the same for the next one. But where it's strange is 1 and 1, the output is 0. Now normally, since 1 and 1, normally the output will be 1. And exactly the same with the XNOR gate. I should have explained really the XOR gate before the XNOR gate really, so that's my apologies. So as you can see, in the XNOR gate, when both of the input values are the same digits, i.e. whether they're both 0 or both 1, the output is 1. Whereas with an XOR gate, if they're both the same, i.e. both input values are 0 or 1, then the output is 0, so it's the opposite. So XNOR is the opposite of XNOR is the opposite of XOR. So I'll just reiterate again. I'll reiterate from the start. So a NOR gate is the opposite of the OR gate. So the output is only high when neither A or B is high. So the only time the output value of a NOR gate is 1 is where both input values are 0. So as you can see, A and B both have 0 input values, so the output is 1. Whereas in a normal OR gate, every value apart from where the input values are both 0 will be 1. But since the NOR gate is the opposite of the OR gate, everything's going to be inverted. It's quite easy really, you just need to look at the OR gate and see where it is 1. And if you want to make a NOR gate truth table, just do the opposite in the output. So if there's a 1 in the first column in an OR gate, then if you're going to do a NOR gate, you put a 0 in that output. I'll switch to the XOR gate first. So XOR looks the same as XNOR, apart from the lack of the inverter, the little circle, and the output of the XOR gate is high when one input value is true and the one is false. So both input values are true, i.e. they are both 0 or both 1, then they are false. And the output is 0. So a plus sign with a circle around it represents XOR. And there we go, so it's just, if both input values are 0, then the output will always be 0. And as I said, it's quite strange because they're both 1. You'd always expect the output to be 1 if both input values are 1. But that's not the case with the XOR. But with the XNOR, it's the opposite of XNOR, it's the opposite of XOR. So obviously, when the input values are going to be both 1 or both 0, the output will be 1. So as you can see, an XNOR gate is a NOR gate with the line across it, crossing the input value lines. The circle with a plus and line over it represents the XNOR gate. The output is only 1 when both input values, i.e. A and B, are either both high or both low, so they're either 1 or 0, i.e. the output of an XNOR gate when the input values are both with 0 is 1, whereas if an input value is 1 and the other is 0, the output is 0. So it's just the same. So if you had an XOR gate, so you know that if both input values are 0, the output's going to be 0. So if you know you want to do an XNOR gate, all you do is switch the outputs of the XOR gate and draw it, and then there you go. So hopefully you've learned something. I think I might put the link to the presentation download in this one, because I think I might have presented it wrong. I should have put the XOR gate before the XNOR gate instead. But hopefully you've learned something about logic gates. It is quite interesting, especially with the mathematical side. You know, it's just a bunch of ones and zeros. I might do a binary tutorial next, because that was interesting. You know, it's like 1, 1, 1, 0, 0, 0, 0, and all that. So yeah, hopefully you've learned something. If not, just like it and say what I can do better in the comments. And yeah, thanks for watching. See ya. Bye.